All right, let's talk area. Today we're going to focus on three particular shapes: parallelograms, triangles, and trapezoids. Whenever we're talking about area, we are talking about the amount of space enclosed by a geometric figure. Whenever you were younger and you first started learning about area, you would literally count how many little squares would fit inside of a rectangle. Okay, so for that reason, when we measure area, we use square units. You guys know now that if you're finding the area of a rectangle, you can just multiply the length by the width, and that will tell you how much space is on the inside. Okay, here we go. Let's keep moving. So perpendicular is an important word that we need to understand whenever we're finding area. Perpendicular is whenever you have two lines that intersect and form a right angle. All right, let's take a look at a parallelogram. A parallelogram is just any two-dimensional shape that has two sets of parallel sides. So here you see some examples of parallelograms. Oftentimes, people describe them as kind of a slanted or a crooked rectangle. Okay, a rectangle would actually be a type of parallelogram, and a square is a special type of parallelogram. They all kind of go together. Okay, so anytime you have a parallelogram, we can use this formula here. Remember, a formula in math is like our rule that we can use. So anytime you have a parallelogram, we are going to do A equals BH. Okay, so whenever you have those two variables right next to each other, that's a symbol of multiplication. So in order to find the area for a parallelogram, we need to multiply the base times the height. Now, it's important to remember that word perpendicular that we were just talking about, because the base and the height have to be perpendicular to each other. So if you look at this first parallelogram up here, you see they have the base highlighted in red, or I'm tracing over it, and then the height is drawn in as that perpendicular distance from the top to the bottom. So these slanted sides over here, they're just sides of our parallelogram. They are not the height. So we don't need those whenever we are calculating the area. Okay, if you look down here at our yellow parallelogram, you can see in this one they drew the height outside of the parallelogram. So sometimes you'll see it drawn on the inside of the parallelogram, like on the top, and then sometimes they use that dotted line and they'll draw it outside the parallelogram, like we see here in the bottom. Okay, either way, if we want to find the formula, we're going to do area equals base times height. I like to write the formula each time just because it helps me remember and think about what I'm going to do. So when I look at this, I see I'm going to have to do 8.2 times my height of 4.5. Okay, so that means right now 5 centimeters is just the length of that slanted side. It's extra information. I do not need it in order to calculate the area. Okay, so I'm going to multiply those. If you don't have a calculator handy, you're going to want one. So I would pause the video and go find a calculator and then come back if you need to. Okay, if you have one there, then go ahead and let's multiply 8.2 times 4.5. And you'll get 36.9. We're measuring in centimeters, and then we can use the little 2 as our exponent, and we read that centimeters squared. So 36.9 centimeters squared is the area of that parallelogram. Okay, let's take a look at a couple more. So if we're looking up here at our top parallelogram, remember we always do area equals the base times the height. The base and the height have to be perpendicular to each other. So I'm going to use 75 as the base and 50 is the height. Again, 63 is just extra information. It is the length of that side. And while that's nice to know, we don't need it to calculate the area. Okay, so 75 times 50 will give us 3,750 millimeters squared. Okay, I also want to show you one last thing here as far as parallelograms go. If you look at the bottom, the parallelogram is drawn in on a grid. So sometimes you might have this and you'll have to find the area of the figure based on the grid. Okay, so you have to calculate the length, or what we call the base, and the height. Okay, you could count all the squares inside there, but it's going to get tricky because you can see that with these slanted sides we have some partial squares. Okay, and whenever you're finding the base, you're going to count from one corner to the next. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. And then you have to find that perpendicular height. So I'm going to go this direction right here, perpendicular top to bottom, and we have 1, 2, 3, 4, 5. So the area of this parallelogram would be 45 units squared. All right, now if you take a look at the picture here, what shapes do you see? Okay, hopefully you're seeing some parallelograms and also some triangles. So I like to show this because it helps us to see that any parallelogram can be split into two equal triangles. Okay, and that's important to know as we move on to our next shape, which is a triangle. So here we go. To find the area of a triangle, we use the formula base times height divided by 2. So base times height was just what we did for our parallelogram, and then we're going to divide it by 2. Okay, remember we just said that any parallelogram can be split into two congruent or equal triangles. So if we take our parallelogram and divide it by 2, we'll have the area for a triangle. Okay, so any triangle that you have, you can always use this formula, base times height divided by 2. And just like with our parallelogram, the base and the height have to be perpendicular. Okay, so this picture right here is just showing that height drawn in to be perpendicular to the base. This triangle is what we call a right triangle. So this side is actually already perpendicular to the base, so you don't have to draw in a special height. It's just going to be that side. Okay, base and height always have to be perpendicular. Let's try it. Here we go, find the area. So for the first one, okay, again, I like to write that formula first just to help me remember what I need to do. It's like this algebraic expression, and then we're going to replace the variables with the numbers from the picture. So the base of this triangle is 12. The height of the triangle is 9 because it's perpendicular to the base, and then I have to divide by 2. Okay, so this 11 centimeters is extra information as far as the area goes. Okay, and then we can go ahead and simplify our expression. 12 times 9 is 108. And then we're going to divide that by 2, and 108 divided by 2 is equal to 54 centimeters squared. Okay, why don't you go ahead and pause the video, see if you can find the area for the next triangle, and then you can hit play and see if you got it right. Okay, and our third shape that we're going to be talking about is a trapezoid. A trapezoid is a two-dimensional figure that has one set of parallel sides. So the parallel sides are referred to as the bases. Okay, you can see this trapezoid, it looks like the top and the bottom are called the bases or the parallel sides. Now, I don't like to get in the habit of saying that the bases are the top and the bottom, because we could turn that trapezoid on its side, like this blue one that we have down here on the bottom. And now my bases are, not the top and the bottom anymore. So it's important to know the bases are the parallel sides of your trapezoid. Okay, and then we have the height that is perpendicular to the bases. Now, This is the formula that we use to find the area of a trapezoid, and it looks a little bit overwhelming, okay? But we're going to break it apart, and hopefully it won't be so bad here after the next minute or two. Okay, if we were together in class, I would show you a cool little demonstration with paper and to show you how a parallelogram and a trapezoid are kind of related and how they came up with this formula. But for now, I'm just going to show you how to use the formula. Okay, so we have 1/2 times the height. So the height is the part that's perpendicular to your bases. So you have to figure out what half of that is. You can either take the height times 1/2, or you could do the height divided by 2. That means the same thing. Okay, and then you'll see that's right up next to the parentheses here where we are adding those bases together. So base 1 plus base 2, and then you multiply that by half of the height. Okay, so let's try it with our blue trapezoid here. So again, I always like to copy down that formula just to help me remember what I'm doing. And for the time being, I will always give you those formulas. You don't have to memorize these, okay? You guys can look back at these notes, and whenever you're answering questions and practicing, you'll have access to these formulas. So you don't have to memorize them, you just have to know how to use them. Okay, here we go with our blue trapezoid. So I'm going to do the parentheses first, and I'm going to add those bases. So I see 10 plus 14. Okay, I'm going to keep it in the parentheses, and then I need half of the height. So half times 6, or you guys know that half of 6 would be 3. And then we have, again, the sum of the bases. So 10 and 14 are going to add up to 24, and we're multiplying that by 3. So 3 times 24 would give us 72, and we're talking about feet here. I'm going to run out of space. I'm going to write it over here. So 72 feet squared. Okay, let's try one more. Okay, here's a nice big trapezoid. So again, our area is equal to half of the height times base 1 plus base 2. Just don't quite have enough room. Okay, so let's go ahead and plug our numbers in. So the bases, again, are the parallel sides. So that's going to be 8 feet and 12 feet. So we're adding 8 and 12, and then we would multiply that by half of the height. The height has to be perpendicular, so we're going to do half of 8. Okay, and 10 feet is the length of this side, so it's extra information. We don't need that for the area. Okay, so here we go. Following the order of operations, 8 plus 12 is 20, and we're going to multiply that by half of 8, which is 4. So 4 times 20 would give me 80 feet squared for the area of our trapezoid. All right, and one last thing. So here is kind of a summary of each of the formulas that we just talked about. So if you guys want to take, excuse me, goodness, if you want to take a screenshot, this would be nice to just keep handy. That way as you go through the practice problems, you can refer back to this. I also have included this in the notes that are PDF attached on Schoology. All right, good luck.